In this video, we're going to find some derivatives using the general product rule and the general quotient rule. Calling them the general product rule and general quotient rule because they're going to involve the chain rule. So we've generalized them. The derivative of the inner function is no longer going to be 1, so it's not going to be necessarily simple. So let's go ahead and get started here with number 49, which says f of x is equal to x times 3x minus 9 to the third. Now I can actually make this simpler by factoring out a 3 to the third, but I'm going to deal with this the way that's written and then simplify it at the end so that I get the idea of the general product rule here. So I'm going to call this u times v. And so u is going to be equal to x, and v is going to be equal to 3x minus 9 to the third power. So that makes u prime, my derivative of u, equal to 1. V prime is going to be 3. My power is 3. That multiplies out front here, times my base is 3x minus 9. 3 minus 1 is 2, times the derivative of the inside will also be 3. Making v prime 3 times 3 is 9, times 3x minus 9 to the second power. So my f prime of x, since this is a product rule, is going to be take the derivative of the first, leave the second alone, plus derivative of the second, leave the first alone. You may do that in opposite orders, that's fine, since it's a product and it's a sum. Order doesn't matter a whole lot, just take the derivative of one part, leave the other part alone, and then take the sum of, take the derivative of the part that you didn't differentiate the first time and leave the part that you differentiated the first time alone, like that. So let's go ahead, and f prime of x is, my u prime here is 1, and my v is 3x minus 9 to the third, plus v prime is 9, is 3x minus 9 to the second, and my u is x. I have a common factor here of 3x minus 9 to the second power, and that's going to leave me with 3x minus 9 plus 9x. So we have 3x minus 9 to the second, times 3x plus 9x is 12x minus 9. Now I told you I'm going to factor things out to make it look more like how the book did. So this is going to be 3 times x minus 3 that was squared. I'm also going to have a 3 times 4x minus 3 here. So this 3 is squared because I have 2 of these. Let's just write them both out. Like so. 3 times 3 times 3 is going to be 27. And then I have x minus 3 to the first, and another one is 2 times, and then I have a 4x minus 3 at the end, and that's the answer that's in the book. Let's go ahead and look at number 51. Number 51 has y is equal to x times the square root of 2x plus 3. So u is equal to x. V, I'm going to call 2x plus 3 to the 1/2 power. U prime is going to be 1. V prime is going to be 1/2. 2x plus 3 to the 1/2 minus 1 is a negative 1/2, times the derivative of the inside is 2. 2 times a half is 1, leaving me with 2x plus 3 to the negative 1/2 power. I want to leave everything in exponential form right now for the sake of factoring in a little bit. Y prime is going to be u prime v plus v prime u. So y prime is going to be 1 times 2x plus 3 to the 1/2 power plus x times 2x plus 3 to the negative 1/2 power. I see a common factor of 2x plus 3 to the negative 1/2 power. That's my smallest exponent on something that has a common base. So when I have 2x plus 3 to the 1/2 minus a negative 1/2 plus, just the x will be left there when I divide that out. Negative 1/2 minus a negative 1/2 is negative 1/2 plus 1/2 is 0. And that base goes away. But this is going to be y prime is 2x plus 3 to the negative 1/2 times 2x plus 3 to the 1/2 plus 1/2 is to the first power plus x. So that's going to give me a numerator of 3x plus 3 and a denominator of 2x plus 3 to the 1/2 power, or I have 3 times x plus 1 over the square root of 2x plus 3. That was number 51. Although this next one isn't a suggested homework problem, I'm going to go ahead and do it anyways, just because it involves the quotient rule. I did 2 product rule problems. I want to do at least 1 quotient rule problem. So I'm going to look at number 55 here. Number 55 says y is equal to 6 minus 5x over x squared minus 1, and all of that gets raised to the second power. So let's go ahead and figure out what my outermost function is here. Y prime is going to be, I'm squaring, so I want 2 times my base, then drop my exponent by 1, times the derivative of that base, like that. So how am I going to find the derivative of that base? Well, I'm going to say y prime equals 2 times 6 minus 5x over x squared minus 1 times the derivative with respect to x of something that's in the form of u over v. So that's going to be y prime equals 2 times 6 minus 5x over x squared minus 1 times, and then this formula is u prime v minus v prime u all over v squared, where my u is equal to 6 minus 5x, and my v is equal to x squared minus 1, making my u prime equal to a negative 5, and my v prime equal to a 2x. So let's substitute here. Y prime is 2 times 6 minus 5x over x squared minus 1 times u prime is a negative 5 times v is x squared minus 1 minus v prime is 2x times 6 minus 5x all over v squared. Let's simplify that numerator. I know this denominator has 3 of the x squared minus 1s right now. This is a negative 5x squared plus 5, and then minus 12x plus 10x squared. So that gives me y prime is 2 times 6 minus 5x times negative 5 plus 10 is 5. And writing this in descending order of exponents, I have minus 1 cubed. And that's my final answer. 5x squared minus 12x plus 5 doesn't factor anymore. So we used the chain rule along with the quotient rule because it's the general quotient rule here, since I had functions inside of functions that I was differentiating. So that's it for this video. And we'll come back next time and we'll talk about some application problems, some business application problems, some life science application problems, just some different applications of these concepts from this section. So see you for the next video.